All right, we're going to start reviewing today for our test, which is Thursday. Okay, so ready? We got this big problem. The whole first page is the first problem. So here we go. Let's see if we remember what we're supposed to do with this. We are going to sketch it, and we are going to list all of our steps. So horizontal and vertical, x-intercept, y-intercept, and hold. And remember, these are points, and these are going to be equations. Right? So how do we start? We start by factoring. So we have to factor everything. So how does it factor? Minus 3 plus 2. And then minus 2 plus 2, either order, right? Then what do you notice right off the bat? Cancel. And that immediately tells me that I'm going to have a hole where x is negative 2. Right? Guys, look at, we're canceled. The hole is negative 2. All right, how do I find that number? I'm going, what I have left here is this. So I'm going to plug negative 2 in there. And you usually get something weird, that's fine. Negative 2 minus 3 is negative 5. And negative 2 minus 2 is negative 4. But a negative over a negative is a positive. So I'm going to plot that point at negative 2, positive 5/4. And you can always type 5/4 in on your calculator and get a decimal, 1.25. So you're plotting at negative 2, comma 1.25. Are we good at that point? So now you still have all the rest of this. So let's look at our problem right here. What else can we fill in right here? What else can we fill in? We have a vertical asymptote at x equals 2 because vertical asymptotes come from the denominator.
Yes.
And then we have a horizontal asymptote at y equals 1. Remember, that was 1.25, so we're underneath that. And we got that by boxing in our x's either here or back at the beginning. It doesn't matter. Either way, you're going to get 1. All right, now what about my intercepts? X is easy. Where does he come from? The numerator. So my x-intercept is going to be at 3, comma 0. From the numerator, directly from the numerator. And then how do I get my y-intercept? Plug in 0. So if I plug in 0, I get negative 3 over negative 2, which again is 1/2, or I mean 3/2. You guys got to remember to cancel those negatives. So here we are at 1.5. And that's it. So now you have to draw your picture. So what do you think? Can you see it? Remember, it's always in opposite quadrants. The question you're gonna have is always in opposite quadrants, because it's gonna be just like this. It's gonna have one vertical, one horizontal, one hole. So this one happens over here, sometimes they're here. Got it? That's a whole page of your test. All right, let's move on to part 2, which is some solving. And some of this is what you did on your quiz a few minutes ago. On Monday, no, Tuesday, we will get back all of our quizzes. So you can look at them. But yeah, one of our quizzes was this problem, right? And the quiz you just took was these kind of problems. So let's start with this one. This one's a little bit different than what was on your quiz. Look at it carefully. What do you think we need to do first? Get 0, exactly. You gotta have 0, kids. So we're gonna subtract that 6x. Are you ever gonna see this problem again? Yes, on your test, right? Different numbers, but you wanna get 0. Get 0. Now what do? Once I have that 0, take out an x. Love it. We call it factoring out the GCF. Take out an x. Then what? Draw my number line. Now there are 2 dots on the number line, boys and girls. One of the dots is at, that isn't 1. If it were 1, it'd say x minus 1. Is that what it says? No. 0 and 6. Your dots are at 0 and 6. A plain x is always 0. Those dots should be colored in. Now if you want, you can use your shortcut on this one, because there's 2 dots. There's none of this, right? That would mess everything up, but it's not there. It's greater than. Out. So negative infinity to 0. Or 6 to infinity. If you don't want to use the shortcut, what could you do? Pick a number. Exactly. Pick a number. Picking a number will always work. It takes longer, it's kind of a pain in the butt, but it will always work. All right. Problem B is probably the hardest one on the test, because there's just a lot to do. It's not, hard's not the right word. There's just a lot to do. So what do you think we'll do first? Subtract 6. And remember that that 6 is really a fraction. 6 over 1. I didn't worry about that over here because this wasn't a fraction either, but now here, this is a fraction. This a fraction. And now what am I gonna do? I'm gonna make the denominators the same. I have 2 fractions. In order to do the problem, I can only have 1. So I have to put these together. And in order to put them together, they have to have a common denominator. So I am gonna multiply this by x plus 3. Okay? So what have I got? My bottom is x plus 3. What is my top? X minus 2 minus 6x minus 18. We have to be really careful with that arithmetic. We're distributing minus 6, so minus 6x minus 18. All right, let's clean up that numerator. What is that? Negative 5x minus 20. I'm ready to put dots on the number line now. 1x on top, 1x on the bottom, 2 dots on the number line. I know the bottom dot is going to be at negative 3. The top one is confusing to me. So do you remember how I told you to handle that? What do? If you can't, like this one I can eyeball.
Take out.
I am going to set it equal to 0 and solve it. So I get negative 4. Now Gabby said I could also factor out a negative 5. And wouldn't that give me the same negative 4? So I have negative 4 and negative 3 as my dots. Am I coloring them in or leaving them open? Actually, some of both, right? Because this tells me to color, but denominators can't be colored. So the negative 3 is staying open, but the negative 4 is closing.
Why is the 4 a negative 4, not a positive 4?
Because when I solved it, I set my numerator equal to 0, add 20, divide by negative 5, I get a negative 4.
Okay. And you wouldn't make the opposite?
No, because it says x equals negative 4. If I do what Gabby suggested, factor out a negative 5, then I do the opposite because it's in parentheses. Now, how many dots do you have? 2. Do you have anything like this going on? No. So you should be able to use your shortcut. And normally, a less than or equal to 0 would be shaded in between. But what do you notice about this problem? See that guy right there? What does he do? Flips it. So instead of shading inside, you're going to shade outside. You guys, that is a lot to keep track of. I am with you 100%. So again, what can you always do? If you're not sure where to shade, what can you always do? Pick a number. Pick a number. And when you pick a number, it will always alternate the shading. Shade, not shaded, shade, not shading, as long as you don't have a squared in your problem. As long as you don't have that in your problem, you can pick one number. If it works, shade, don't shade. If it doesn't work, don't shade, don't. Or you can remember the shortcut, but it's a little tricky because you gotta pay attention to that. So, your answer regardless is this. We can't get so excited if we forget to write our answer. That is our answer. The shaded part is the answer. If, when we had done this problem, if that had been a positive 5, I would have shaded in between, because less than is in between two dots, but it was a negative. All right, we all look kind of dumbfounded. Let's take a look at this one. Okay,
Subtract the 15
absolutely. Actually, we'll add it over.
and then add it, and then factor.
And then what do? That is right. When you're doing these, when you have this symbol in inequality, you gotta have a zero. Remember the last problem? Oh, actually, both the problems we've done, we got zero. By the way, we skipped C because we did it yesterday. It should already be filled in for you. We did it yesterday. Okay. Now what? Yeah. We would love to do this grouping, but look at those numbers, guys. Are you gonna be able to do anything over here? So you can try, but you're not gonna be able to group it. So if I can't group it, then I have no choice. I have to do my PRRs and synthetic division. So this one's not bad. What are your PRRs? 1, 3, 5, and 15. So you guys always want to guess 2. Don't. It's not a possibility this time, right? So don't guess 2. What do you want to guess? 3? Kyle says 3. 3 isn't gonna work. Negative 3 might work. Now let's talk about that. Look at the problem. Think about these numbers. Think about putting a positive 3 there. How do I know it isn't going to work?
Because it's always gonna be positive.
Aren't they just gonna keep getting bigger? Because it's positive? So there's no way I'm ever gonna get a 0? So I'm gonna go with negative 3. You don't have to think that. You're gonna try 3 and it isn't going to work. But if you do think about it, it saves you the trouble. All right, I don't know if negative 3 is gonna work or not either, but let's see. Oh, yeah, it does. Perfect. Now, I would immediately go to my number line and put negative 3 on it. Because when you do this synthetic division, any number that gives you a 0 goes on the number line. And it's easy to forget. So put that one on the number line. Then what? Take the part that's left, which is x squared plus 6x plus 5. Everybody see that right here? Anything paying attention? This, we're getting that right here? And then what do I do with that? Factor it. And how does that factor?
Plus 5, plus 1.
Plus 5, plus 1. Now, we have had problems in the past that didn't factor. You had to use the quadratic formula. I promise it will factor on the test, but if you wanted to use the quadratic formula, you still could. But it will be a factorable problem. And then this tells me where my other dots are. Where are my other dots? Negative 5 and negative 1. Shall I close in all those dots or open some? What do I do? All closed. The only time they wouldn't be closed, when I see this symbol right here, the only time they wouldn't be closed is if they're in a denominator. We don't even have a denominator. All closed. Now, my shading is going to alternate. I just gotta get the ball rolling. The easiest number to pick, you can pick any number you want that's not a dot, but 0 is the easiest. Because if you come back to this right here, and you put in zeros, you do not need to do any math. Because if you put a 0 here, it's 0. 0. 0. All that's left is 15. Is 15 less than 0? No. So I will not shade where the number 0 is. Well, where on the number line is the number 0? Right out here? So I don't shade that. It didn't work. Which means I will shade this one, won't, will.
I go to the bathroom.
Yes, I presume it's an emergency. Here, let's take a pass. I don't wanna get in trouble. All right, so what's my answer? Negative infinity to negative 5, or negative 3 to negative 1. All right, got it? All right, let's look at the next one. Now, notice the next one does not have an inequality. So that means we will not do a number line. We only do a number line when we see things like this, right? Those are number line symbols. This one, we're just going to solve, and the answer is going to be x equals something. So take a look at it, think for a moment, what do we need to do? Is the denominators all the same? What's gonna be your, what do you wanna make all the denominators be? You can make them be whatever you want.
50.
What?
50.
50? That'll work. So this, and an x.
Yeah.
So this one needs a 10 and an x. This one needs a 5 and a 10, which is her 50. This one needs a 5 and an x. Now I know what some of you are thinking, and it's okay. Some of you are thinking, I want to make my denominators all 10x. That's fine. You will get the same answer. Once we've made all the denominators the same, whatever it is we made them, they're the same. Then I'm going to solve the top. So 90x, this is multiplication, plus 150. You will have your calculator to help you with the arithmetic, equals 35x. Subtract 90x, 150 equals 55x. So x negative, x equals 150 over negative 55. Which is negative 30 over 11. Or some of you are going to type that in on your calculator. It's not as good to type it in, but you need to type it in and do that. Yes, ma'am. All right, does everybody see the difference between that one and the one we did right before it? Yeah, this is an equals. And an equals, you want to make your denominators match. There's no number line. Okay. F is an equals. What do we want to do with letter F? factor that guy right there. And these problems are always rigged. So how do you think this is going to factor? Just like those. So 2x minus 3, x plus 1. If you're worried about that, you just want to double check it, you can FOIL this, just like always. Okay, now what do I do? Get a common denominator. And won't our common denominator be both of these? So this one is gonna need the x plus 1, top and bottom. This one is gonna need the 2x minus 3, top and bottom. And that one doesn't need anything because it already has the denominator.
What happened to that, like the x on the numerator, like the negative 8x?
That guy right there,
No, like negative 8.
The negative 8 has an
that,
X.
does it have an x? Oh, yeah. That's, I just copied it wrong, thank you. That would have made a difference in our answer for sure, thank you. No, it's still there. Okay, what happens now? All my denominators match. So what happens now? They're gone. They're gone. So I'm going to distribute on the top. So I have 4x plus 4 plus 2x squared minus 6x equal to negative 8x.
Where do you get the 6x from?
Oh, I don't know. It's a 3. Thank you. Someday you'll be old. Yeah, I distribute. So 2x squared minus 3x. All right, now what? So clean it up a little bit. So we got 2x squared plus x plus 4 equals negative 8x. Did I do that right?
Yeah.
Then I'm gonna have to do what?
Or,
Add the 8x over here. So I'm gonna have 2x squared plus 9x plus 4. We're gonna add that 8 over here. Now what? There's that. Now I cannot take that 2 out, so my factors are gonna have to be 2x and x. And I'm gonna put a 4 here and a 1 here, because remember, when I FOIL, don't these get multiplied? So that would give me 8, and this would give me 1, and that's how I get the 9. So 2x plus 1 equals 0, x plus 4 equals 0. Looks like x equals negative 4, and x equals negative 1/2. A lot going on in that problem, but my guess is the hardest part for you is gonna be the factoring. Trial and error. Alright, how are we? We good? 2 more problems, that's it. That'll be the whole test. 2 more word problems. One of the word problems is solution problem. So for problem 3A, we good with problem 3A? Set up? Some of you like to skip steps. I would not. I would start with putting in my percentages. What is the decimal for 9%? 0.09, yep. And then 3%, and then 5%. Please make sure that you are getting 2 digits there for your percent, 0.05, 0.03, 0.09. How much must be mixed to get 15 gallons of the 5%? So the 15 goes right there. What does that mean is gonna go right here? 15 minus X. And it has to be 15 minus X. It can't be the other way around. It's 15 minus X. So 0.09X plus, I'm doing a distributive here. This is a distributive. Keep an eye on my arithmetic. I did that without a calculator and the way my day's going. All right, what happens now? Aren't these two on the same side of my equation? So they need to be added together, so 0.06X. Now I can subtract 0.45. You guys gotta be able to do this on your own, come on, just solving an equation. I got 5 gallons. Anybody else get 5 gallons? Perfect. One more problem. Will and Zane are painting a fence. It takes Will 15 hours by himself. How long does it take Zane? What's our setup? 1 over 11. 1 over 11. 1 over 7. What do I do with the 12? Will and Zane can paint a fence together in 12 hours. So doesn't the 12 go right here? Will 15 hours alone. How long is Zane alone? Everybody got that set up? Makes sense? Good. Now I need a common denominator. Do whatever denominator you want. It doesn't make any difference. But one simple way to approach it is to say, well, the common denominator has to have a 15 and a 12 and an X. There's other things you can do, but it's gotta have those. So a 15 and a 12, and a 15 and an X. Once every denominator has what it has to have, 12x, remember this is all multiply, so 12x plus 180 equals 15x. Oh lordy, does it take poor Zane 60 hours to do that job? Okay, all right, here's what we're gonna do, we got 7 minutes, so here's what we're gonna do. We're gonna have somebody or somebodies come up. We did not do a problem today because we did it yesterday for quiz practice, but I need somebody, whoever, to get up here and make this problem. And the rest of us are just gonna practice it on our own. As soon as we get this one done, we're done for the day, so let's get our volunteers up here and get going. Love to go get them attitude, boys, thank you. So help me if I see anybody just sitting there, I might snap you. Everybody should be working on this problem. Numbers are the boys gonna have to try? 3. This problem has a squared in it, so you have to try every section, and you have 3 sections, so you'll try 3 different numbers. Totally love that answer. There's one, it's tricky, we haven't run into it very much. Your answer is everything, what?
Is it these open?
No, the circles are, no, his dots are closed because of this sign right here. That part's right. That part is absolutely right. This is not shaded, this is not shaded, that is shaded. But your answer is everything that's shaded, including, see that little dot right there? He's actually colored in, isn't he? So your answer would be that, or just plain old x equals -2. That dot is part of your answer.
That's a trick.
That is tricky. I didn't know it would happen, but yeah, that is tricky. That is tricky. Good work. Is everybody okay with their shading? This is the only place that got shaded.
I tried to do it.
No, before it didn't work in my head.
In class, you just say something at the end that, like, say,
Think about,
What?
like,
What?
if I shaded, if I put my hand somewhere,
What'd you
it's a different color. So I brought
Why are you talking about that?
You say, oh, I feel like listen to you like when you're talking to somebody else, but yeah, I know what you're talking about. No, you don't.
But every single time I have
and then I check my shading.
remember, I was supposed to look at you like, what? What are you talking about?
I'm not talking about
he wants to look on our end so bad.
Hey, Ethan, I'm just calling Ethan. Hey, Ethan.
All right, next time I see you, we'll do practice test 2, then we'll do 3, and then we'll take our test.